we did it. 26th. Please write down this question. Highest power of 2 in 10 factorial plus 11 factorial plus 12 factorial and so on up to 1000 factorial. What is the highest power of 2? Most of the students will do a mistake. I don't know who taught them this kind of weird logics. They will take for 10 factorial. 2 5s are, 2 2s are, 2 1s are. 5 plus 2 plus 1. They will tick mark the answer as 8 without even thinking mathematically. Why you are taking 10 factorial? Directly you will write it. This is a blunder mistake. This is a blunder mistake. This is a mistake. Most of the students will do it. I don't know what kind of teaching they have gone through it. Now see here. Solution. N, let me call it as N. N is given as 10 factorial plus 11 factorial plus 12 factorial and so on up to 1000 factorial. 10 factorial plus 11 factorial and so on up to 1000 factorial. 10 factorial. 11 n factorial can be written as n into n minus 1 factorial. 12 factorial can be written as 12 into 11 into 10 factorial. 13 factorial can be written as 13 into 12 into 11 into 10 factorial. 14 factorial can be written as 14 into 13 into 11 into 10 factorial and so on. Is this clear? Why are we expanding it? You will come to know. Let me take 10 factorial common. Let me take 10 factorial common. 1 plus 11 plus 12 into 11. 13 into 12 into 11. 14 into 13 into 12 into 11 and so on. Are you all with me? So again 1 plus 11 it is 12. Here 12. Here 12. Here 12. So 12 if I take common. 10 factorial into 12 into 1 plus 11 plus 13 into 11. Remaining it is 14 into 13 into 11 and so on. Are you all with me? Over answer. Now see here, logically, 14 into 13 into 11, it is even, any number of times even number, answer will be even. 1 plus 11, it is 12, even. 13 into 11, it is odd. Even, it is even. Plus even, it is even. Plus odd, it is odd. That means I will get finally 10 factorial into 12 into odd. 10 factorial into 12 into odd. 10 factorial power of 2 is 8 into some other prime bases. 2 square into 3 into odd. 8 plus 2. Answer for this question is 10. Answer for this question is 10. Very, very good question, which will make you understand. In your textbooks, you have done factorial highest powers, or probably you have done 2 factorials or the subtraction of 2 factorials. Subtraction of 2 factorials. You have done that one. But so many factorials are added. He is asking you the highest power of 2. 11 factorial. What are the concepts that we did here? N factorial it is. N into n minus 1 factorial. Or it is n into n minus 1 into n minus 2 factorial. n minus 2 factorial. 11 factorial is 11 into 10 factorial. 12 factorial is 12 into 11 into 10 factorial. 13 factorial, 14 factorial. 10 factorial if I take common, 1 plus 11 plus 12 into 11 plus 13. Here I took 12 common. Here 12 is there, here 12 is there, here all 12 are there. From 14 into 13 into 12 into 11, I got even. Even. Answer will be, sum will be even. 1 plus 11 it is 12. 12 it is an even number. Even plus even plus odd, it is an odd number. I hope the question concept it is clear. Question concept, I hope it is clear. Most of the teachers will tell this. Tell that number of zeros at the end, it is highest power of 5. Number of zeros at the end. Number of zeros, it is an half knowledge statement, sir. Number of zeros at the end, it is highest power of 5. Almost all the teachers will say, but my statement is, it is only applicable for factorials. It is very, very important key point. Please make a note, sir. Only applicable for factorials. Only applicable for factorials, not always. Most of the students will think that just if I find the highest power of 5, I will get the number of zeros at the end. It is not true. Put it as extremely important key point. Very, very important key point, sir. Very, very important key point. Extremely important key point. Number of zeros at the end, it is the highest power of 5. It is not applicable for all the numbers. For certain numbers, power of 2 also can give. Power of n is the product of all odd numbers. Product of, very, very good question, sir. Product of all odd numbers. All odd numbers till 199. M into n gives dash number of zeros. M into n gives dash number of zeros at the end. Write down the question, sir. Extremely important question. Extremely important question. M is 2 into 4 into 6 into 8 and so on up to 24. N is the product of all odd numbers till 199. M into n gives dash number of zeros at the end. You can also teach the teachers this point. Number of zeros at the end is not always highest power of 5. It is only applicable for factorials. Listen carefully. Solution. Listen carefully to this question. M is 2 into 4 into 6 into 8 and so on up to 24. So this is 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 twelves are 24. 2 is multiplied 12 times. 2 is multiplied 12 times, 2 power 12. 1 into 2 into 3 till 12. So it is 12 factorial. M is 2 power 12 into 12 factorial. Till here it is clear. In the next slide, complete slide, we will use it. Now, product of all odd numbers till 199. So n will be 27 from 27. From 27 till 199. Please write down, sir. Product of all odd numbers from 27 till 199. So this will be 27, 29, 31, 33 till 199. Till 199. Number of zeros at the end, it is the power of 10. 10 is a composite number. It is 2 into 5. So I need the multiples of 2 and 5. Odd numbers. In odd numbers, odd number is a number which is never divisible by 2. So that means 2 will not come. So only, shall I write it down in the next slide? So M will be 2 power 12 into 12 factorial. N is 27, 29, 31, 33 and so on up to 199. What do I require? M into n gives dash number of ending zeros. Zeros at the end are also called as trailing zeros. M into n gives dash number of ending zeros. Listen carefully, sir. These are all odd numbers. Odd numbers will not have any powers of 2. Only concentrate on the odd multiples of 5. 27, 29, 31, 33, 35. 37, 39, 41, 43, 45. So there is a difference of 10. 55. Next is 65. Next is 75. Next is 85. Next is 95. 105. 115. 125. 135. 145. 155. 165. 175. 185. And 195. 195. Now listen carefully, sir. Right? Very, very good question which it will teach you. Number of zeros at the end is not always highest power of 5. M is 2 power 12 into 12 factorial. Now listen carefully. M. This is 12 can be written. What is the highest power of 2? 2 6s are, 2 3s are, 2 1s are. So it is 2 power 12 into 2 power 10 into 12. What is the highest power of 5? 5 square into k. Is it clear? So m is 2 power 22 into 5 square into k. N is, how many 5s are there? Let us see. 5 7s are 35. 5 1 multiple of 5. 5 9s are, 5 11s are, 5 13s are, 25 3s are plus 2. 5 17s are, 5 19s are, 5 21s are, 5 23s are, 5 cube is 120 plus 3, 5 27s are, 5 29s are, 5 31s are, 5 33s are, 25 7s are, 5 37s are, 5 29s are. What is this? Plus 1, plus 1, plus 1, plus 1. 5 7s are, 5, 1 power of 5 is there. 5 9s are, 5 11s are, 5 13s are. Totally how many I got? 2, 3, 4, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 19, 20, 21. 21. 5 power 21 into some other prime basis. So m into n will give you, what is the value of m? 2 power 22 into 5 square into k. N will be 5 power 21 into k2. So this will be 2 power 22 into 5 power 23, k into k2, k3. So this will be 2 into 5 power 22 into 5 power 1 into k3. 10 power 22. How many zeros it got? 10 power 1 will have 1 0. 10 power 2 will have 2 zeros. 10 power 3 will have 3 zeros. 10 power 22 will have 22 zeros. From where you got 22, you got 22 from the lowest power of 2. Number of zeros at the end is not always the highest power of 5. Very, very good question. Extremely important question. Only for factorial based problems, number of zeros at the end, it is the highest power of. Number of zeros at the end, it is the highest power of 5. If the question nature changes, then it could be the highest power of 2. Some mistakes which you might do. 12 you have to condense it as a highest power of 2. 2 6 are, 2 3s are, 2 1s are, 2 power 10. 5 it is 5 square. Why I wrote 75 as plus 2 above? 25 into 3. So there are 2 powers of 5. 125, why I wrote plus 3? It is 125 is 5 cube. 175 is 25 into 7. It is plus 2. I hope it is clear. So 5 into 7, 5 into 9, all will get added. Very, very good question, sir. Probably the best question of the day, which will give you an idea that number of zeros at the end is not always the highest power of 5. Good question. I hope you enjoyed solving this question. Next one. Next, if you see here, are there any questions which can be right? This question is a pattern based, so we will solve it directly, then we will go. Question contains numerical values. By this time you should have understood wherever some patterns are there. Question contains numerical values. Answer also contains numerical values. Answer also contains numerical values. Answer contains numerical values. Let us not waste our time in doing the traditional method. What is the method that we will use? Approximation. Or we will take first two values and we will check it out whether the pattern is remaining same. It is B is divided by A. Now, if you see here, if I take the first two values, 1 by 2 factorial plus 2 by 3 factorial, it is 1 by 2 plus 2 by 6, which is 1 by 2 plus 1 by 3, which is 5 by 6. 5 by 6 is A by B. Reminder when B is divided by A. Reminder when 6 is divided by 5. 5 ones are 5. What is the remainder? 1. What is the remainder? 1. Check from n equivalent to 2 onwards. Answer is 1. Check for the next three values. 1 by 2 factorial, 2 by 3 factorial, 3 by 4 factorial. It is 1 by 2. It is 1 by 3. 3 by 24. It is 1 by 8. These 5 by 6 plus 1 by 8, 24. It is, where is the calculation mistake? 3 by 4 factorial, it is 1 by 8. 1 by 2 factorial, 2 by 6, it is 2, 3 and 8. 6 and 8, it is 24. It is 20 plus 3. 23 by 24. B is divided by A. 24 is divided by 23. 24 divided by 23. 20 B 23 ones are 23. What is the remainder? 1. Answer for this question is 1. Answer for this question is 1. I hope it is clear. I hope it is clear. Or the alternative method, 2 minus 1 by 2 factorial, 3 minus 1 by 3 factorial, 4 minus 1 by 4 factorial, 22 minus 1 by 22 factorial. This will result in 22 factorial minus 1 divided by 22 factorial. This kind of approach, avoid it. What is the important learning in this question? Question contains numerical values. Answer contains numerical values. Approximate the values. Question contains numerical values. Answer contains the numerical values. Approximate the values. Approximate the values. Next one. Read this question. What is this question? Product of three numbers. Product of three numbers, it is 1620. HCF of any two out of the three numbers. Three numbers, the product is 1620. Product is 1620. Okay. HCF of any two out of the three numbers. That means either it can be HCF of A comma B, or it can be HCF of B comma C, or it can be HCF of A comma C. Any two out of the three numbers, it is 3. So, A equivalent to 3K1, B equivalent to 3K2, C equivalent to 3K3. K1, K2, K3 are co-primes. Any natural numbers can be written as HCF into something. 6, 9. 6 is 3 into 2. 9 is 3 into 3. 3 is the HCF of 6 and 9. 2 and 3 are co-prime. 3 is the HCF of 6 and 9. And 2 comma 3 are co-prime. 2 comma 3 are co-prime. I hope the idea it is clear. So if I take HCF of 3K1 comma 3K2, 3 is common. HCF of co-prime numbers, it is always 1. HCF, so it is 3. Even if I take 3K2, 3K3, K2 and K3 are co-prime. So it is 3. Or 3K1, 3K3, they are also co-prime. So please write down. A can be written as 3K1, B is the 3K2, C as 3K3. What are K1, K2, K3? They are all co-prime. Substitute it easily, you will get the answer. It's an easy question. A is 3K1, B is 3K2, and C is 3K3. 3K1 into 3K2 into 3K3. It is 1620. 27 into K1, K2, K3. It is 1620. So this will be K1, K2, K3. It is 60. K1, K2, K3. It is 60. What is the question? LCM. What is the LCM of 3K1, 3K2 and 3K3? So these is nothing but common factor. LCM of coprimes is their product. 3 into 60, it is 180. 3 into 60, it is 180. I hope the idea it is clear. So this is a beautiful question which talks about how to use coprime concept. Any numbers can be written as HK1 and HK2. Any numbers can be written as HK1 and HK2. 3 into 2, 3 into 3. 3 is the HCF of 6, 9. 3 is the HCF of 6, 9. 3K1. What are the learnings in this question? See here. These two concepts are used. HCF of coprimes, it is 1. LCM of coprimes, it is product. LCM of coprimes, it is product. Please write down. HCF of coprimes, it is 1. LCM of coprimes, it is the product. This question uses beautifully product related properties. I have to discuss. Find the last 2 digits for 6 power 2005. Traditional method. Then I will discuss Anil Nair's method. Traditional method. Most of the students will solve problem like this. Most of the students. 6 power 2005. 6 power 2005. So multiple methods are there. Method 1 in traditional method and method 2. Method 1 is the last 2 digits of a number. The last 2 digits of a number. Last 2 digits of a number. It is the remainder when you divide a number by 100. When you divide a number by 100. So what they will do? They will do 6 power 2005 divided by 100. 100 is a composite number. So 100 is a composite number. They will use quotient function of 100. 100 is 2 square into 5 square. Please go back and see the reminders class to understand how am I doing. 1 by 2 into 4 by 5. Either they will do like this or they will do 100 as 4 into 25. Chinese remainder theorem. Chinese remainder theorem. This 100 equivalent to 4 into 25 they will do. Numerator and denominator are not coprime. So Euler's method definitely after taking the factors common only we have to do. 6 is an even number, 100 is an even number. This one method they will solve. The next method which they will do is 6 power 2005. They will factorize into 2 power 2005 and 3 power 2005. They will find out the last 2 digits for 2 power 2005 and 2 power 2005 and they will multiply it. It takes 2 minutes to solve this question. It also takes around 1.5 minutes to solve this question. 1.5 minutes to solve this question. Now see here. Now see here, we are getting into a level 3, advanced level. That is the reason it is question number 2. Now, Anil Nair's way of solving. Very, very easy way to solve. Within 5 seconds, you will get the answer. Anil Nair's method. Simple. If a number unit digit is 6, if the power is a multiple of 5, tens place could be any number. Tens place could be any number. Last 2 digits is 76. Last 2 digits it is 76. Directly the answer is 76. A could be any tens place. In our CAT enrolled batch, I gave a proof why it is happening to be 76. Now see here. What are the last 2 digits of 6 power 2005? 2005 is a multiple of 5. Answer directly it is 76. Answer directly it is 76. Let me see the charts. Yogesh, right after the class, you can always WhatsApp this number My team will help you out to get the Telegram link. 80-500-6789. 80-500. I will write it here. 80-500-67891. You can always WhatsApp this number. You can always WhatsApp this number to get the Telegram link. Last two digits of 6 power 2005. You don't need to use method 1 and method 2. Method 1 and method 2. Directly you can use. Some problems we will solve. Some problems we will solve. Find the last two digits for. Find the last two digits for. Find the last two digits for. First question. 36 power 200. Answer is directly 76. 36 power 200. Answer is directly 76. So what is the logic? Any number ending with 6. If the power is a multiple of 5, last two digits will be 76. Last two digits will be 76. Idea clear? A6 power 5k. Directly you will get the answer. 56 power 141. This can be written as 56 power 140 into 56. 140 is a multiple of 5. So answer is 76 into 56. 76 into 56. 56 6 are 336. 33. 56 7s are, this will be 42, 35, 392 plus 3. Answer is 56. Answer is 56. I hope it is clear. Very, very easy question, sir. 96 power 16. It is 96 power 15 into 96. It is 76 into 96. 96 divided by 100 minus 4. Negative remainder minus 04. Positive remainder it is 96. Positive remainder it is 96. Extremely easy question, sir. Suppose if the question is 46 power 37. 46 power 37. It is 46 power 35. Into 46 square. A6 power 5k. Last two digits is 76. 46 square is 50 minus 4 square. Last two digits is 4 square 16. 76 multiplied by any power of 2. Last two digits is nothing but 16. Very, very easy questions. If you get this kind of questions, consider yourself lucky. A6 power 5k. Last two digits is always 76. A6 power 5k. Last two digits is always 76. I hope the idea it is clear. From here onwards, marathon session, Maha Marathon level 2 it is starting. These are all level 2 questions. These are all level 2 questions which involves a lot of understanding of your concepts. Still there are a lot of questions which we can, I think this question which we will try to solve. Let us see if there are. This question, see here, sir. 129 power 131. What is the logic? In the 10 expansion of 129 power 131. Anil Nair's way of solving the question. For me, every question is a very logical question. Anil Nair's method. See here. What is the question that we are solving? Find the digit in the tens place of units place, and it is the tens place. Units place and tens place. What is the question given? 129 power 131. 9 power odd number. 9 power odd number. Unit digit it is always 9. 9 power odd number. Unit digit it is always 9. That means here the 9 is fixed. Tens place we have to do. Now listen carefully, sir. Suppose first option 129 power 131. This can be written as 129 power 130 into 129 power 1. Are you all with me? Finish. You don't need to find the last two digits. Power is an even number. Power is an even number. 29. 4 sevens are 28. It is an odd number. If the power is an even number, then it is a perfect square. Perfect square is either divisible by 4 or it gives a remainder 1. 129 is an odd number. 129 is an odd number. Divisible by 4 will not come. So it is 4x plus 1. 129. 4 sevens are 28 plus 1. So here I got remainder 1. Here I got remainder 1. Answer when divided by 4. Answer when divided by 4 gives a remainder 1. Answer when divided by 4 gives a remainder 1. I hope the idea it is clear. 4x plus 1, 4x plus 1. Now let us substitute some answer option. Second option, 19. 4 4s are 16 plus 3. 19 cannot be. Next, third option, fourth option, 39. 4 9s are 36 plus 3. Third option cannot be. So we eliminated based on the definition of a perfect square 1 and 3. 1 and 3. I hope the idea it is clear. 1 and 3 we eliminated. What is the next step we have to do? Remainder 1. 129 power 131 divided by 100. 100 2s are 200 minus 71 power 131. Negative power odd negative. 1 power any number 1. 7 1s are 7 minus 71. 100 minus 71. Answer is 29. Last two digits of a number is the remainder when you divide a number by 100. 129 power 131 divided by 100. 100 2s are 200 minus 71 power 131. Minus power odd minus. 7 1s are 7 minus 71. Whenever you get a negative remainder, positive remainder is 100 minus 71 will be 29. So therefore, here you will not get 09. Here you will not get 09. You can do it very easily, sir. 129. Directly it is minus 71 power 131. Minus 7 I got. 100 minus 71 is 29. So you will not get 0 and you will not get 4. I hope the idea